Hi, and welcome to today's podcast. Today in CFM, we're going to cover how to create a clean plate using a 3D camera tracker inside of Nuke's 3D system. So for the first thing that we need to do is, this is what we're going to be creating today. We're going to go ahead and remove some shadows and some objects that we don't want on the frame. So we're going to go over this simple technique and how to go ahead and create this clean plate using a Nuke 3D camera tracker. So essentially, the original footage will look something like this, where we will have essentially two elements that we will have to remove from the shot. And this works for other type of shots as well. And in this example, we have a shadow and we have a box with a shadow that we have to remove that we don't want on the frame. So for this project, the final result should look something like this, where we'll have those elements completely removed from the shot and following the camera move as well. So this is an example of the script. We have the footage at the top, we have the camera track here at the bottom. This is our 3D scene. And then on this section, we have our clean plate. We're only going to focus on one side of the clean plate. We're not going to do both. But if by some reason you guys wanted to learn how to do both of them, we'll cover some of that on the lecture. So let's go ahead and start. So I'm going to go ahead and duplicate this footage. And this footage is on your assets folder. So make sure that you drag one of those. You're going to have two clips, and drag one of the clips that you're going to be using. And then the next thing that we have to do is we're going to have to set our project. So in this case, our footage goes from 1 to 101. So let's go ahead and hit S to set our project and set it to 1 to 101, 24 frames a second, and it's going to be 1280 by 720 on the scale. The next thing that we're going to do is we're going to go ahead and create a new Nuke camera tracker. And what the camera tracker is going to allow you to do is going to allow you to extract 3D data out of this 2D image. So for example, we're going to follow this camera move, but the 3D camera doesn't know where anything on this in the real world exists. So by using a new camera tracker, we're going to be able to triangulate positions in the frame in order to be able to extract 3D data out of 2D positions. So the next thing that we're going to do is we're going to go ahead and set up the Nuke's camera tracker. The first thing that we're going to see is Nuke will start with an input area where we're going to go ahead and input the sequence, the frame range that we're going to be working with, and if we're going to be using any masks. Then later on, we're going to go through the camera section where we're going to actually input the information of the camera that we're using to shoot this specific footage. If we have known information, we're going to go ahead and put the known information. If by some reason we have unknown information, we're going to leave it as unknown here. So let Nuke calculate or guess it. So the next thing that we're going to do, let's go ahead and start that process of inputting all the data that we need in order to track the camera. So for this, we know we are going to be tracking a sequence. So you have two options, stills and sequence. And then we're not going to be using any mask input here. So we're going to go ahead and track the whole frame. The next thing is the frame range. If by some reason you leave it to input, it's going to take whatever the input footage frame range is, and it's going to use that to track that information. If by some reason you don't want to track the whole footage, you could actually set it up to a custom footage, and that way custom frame range, and set that up there. So let's leave it as input. The next thing is understanding what type of camera motion we're working with. So in this case, there's different type of camera motions. The two that are the major ones that we found the majority of the times is the rotation and the free camera. So rotation only means if it's only a pan, that means the image is moving left to right, top to bottom, but it's not actually traveling in space. So it's not have this X, Y, and Z movement. Now, when we have a free camera, it's this type of camera that we actually not only have up and down, but we also are traveling forwards and backwards. That means the camera is traveling through the scene, therefore kind of creating a depth information or depth data. So that's what we're going to leave it as, camera motion. And if by some reason you don't understand some of these elements, I'm not going to cover every single one of them, but you could actually go to this little question mark and it will open Nuke help docs. And that way it will go through all the camera settings, so that way you go more in depth into those to understand them. Now the next thing that we need about the camera is the lens distortion. In this case, we're not going to be calculating lens distortion, so we're going to leave it as the way it is. The other thing that we need is the focal length, and the focal length will be the type of lens we were using for this specific shoot. if I was a 44 millimeter, if it was an 82 millimeter, a 24 millimeter, a 28, we'll go ahead and input that information here. If by some reason we knew exactly the information that we were going to put in, we will put known or approximate constant. And essentially we could actually type the lens here. Now in this case, we don't really know the lens that we were using, so we're going to leave it as a known constant. And sometimes you're going to see the varying and the constant. Varying means that it's a zoom lens and is actually doing a zoom on the camera. That's when we're going to use varying. Okay? But in this case, we know it's a lens that doesn't zoom in or out by looking at the footage, so we're going to leave it as unknown constant, so we will let Nuke guess the information. Now the next thing is the film back preset. And in this case, we're using a digital camera, so the film back will be represented as the sensor of the camera. So in this specific footage, we know that we were using a Canon 7D to shoot this. So we're going to go to custom here, go to Canon, DSLRs, and we were shooting video, not still, so we're going to use 7D video. And that's going to give you the sensor size. What this is going to allow you to do is the more information you give to the Nuke's camera tracker, the more accurate the results will be. So therefore, if we knew every single part of the information, the solve or the track that we will get out of this specific footage will be very, very accurate. But in this case, we're going to let Nuke figure out the focal length for us. That way we'll get something approximate. Now the next thing that we're going to do is we have this section called the analysis section. And this is how we actually track and get the information out of the whole system. So the first thing that we're going to do with the analysis section is we're going to click on the track button. And we're going to let that go through. And you're going to see it's going to create all these little features. And what those features are is just 2D tracks in space. So it's the equivalent of you creating manual trackers all the way through the system. So instead of you creating every single one of these trackers, Nuke will do an automatic process or a procedural process. So what we just did was just creating all these features is the equivalent to doing this, creating a new tracker node, okay? And using that tracker node, the same thing that we did with the 2D track, all those features you will have to create it by hand. So essentially that's what that means. So essentially that's what we're going to be kind of working with. So all these 2D trackers, essentially what they're going to allow you to do is to know exactly where all these points are. Now, the next stage of the camera tracker, that is called the solving stage, what it's going to do is going to take all these little 2D features that the camera found, or in this case the Nuke camera tracker found, and it's going to convert those 2D points into 3D data or 3D points in space. And how it achieves that is just based on a concept of parallax. You could go ahead and research a little bit more about parallax. But parallax is pretty much the relation of objects based on distance from each other and the point of view. So in this case, if you actually look at these points and how they move based on our movement in space, you're going to see that we reveal areas behind other objects are in the foreground. And that gives us a relationship in how this camera is moving in the world, or in this case in the 3D space. So that's how it figures out where all these objects are in 3D. So let's go back and let's go ahead and do the solve. So it creates this 3D point cloud data. And you're going to see that as soon as it's solved, it's going to look, you're going to have green points, you're going to have some yellow points, and you're going to have some red points. And what that means is all the green points were the points that were solved and made into 3D. So I'm going to hit tab so you can see those. And there you go. You have what we call point cloud data. And these are all the points that we just calculated in 3D space. Okay. So the ones that are in orange means that they were not solved. That means they're really, really bad. So therefore, I'm not going to even bother to solve them. And the ones in red means that those are rejects. So what we're going to do is we're going to go back and kind of take a look a little bit at the error rate. And that's the next step in our system, is to actually fix a little bit more of the error. So we're going to follow a rule of thumb that if we have a 1K plate, essentially our error needs to be below 1. And pretty much close to 0.5 would be great. The lower we could get it, the better. If we had a 2K plate, errors below 2, 3K, and so on and so forth, 4K, and the same idea. So essentially what we're going to try to do is we're going to try to reduce this error down to closer to 0.5 as we can. The lower we get it, the better. So essentially there's a section in here called the auto track section. That is where we're going to go ahead and refine these things. So first we're going to start with the max error. So select that using the command key and click on error max, and you're going to see all these little spikes. So what we're going to do is we're going to go to the slider called max error, and we're going to lower this error as much as we can without losing a lot of our features. So you got to be very, very careful. You don't want to go ahead all the way down where you lose everything. You want to go ahead and very, very subtle. Just go ahead and see how much you can remove from that shot. Now, on the left-hand side of this graph, you could see the error level. So that means this error is really high over here, higher than 5, actually, closer to 6. So that's a really high error. We will like to reduce that. And then on the bottom, you see the frame range, where that error is happening. So right about there, we get this little jump. And that's essentially what that is. So what we're going to do is we're going to use, by selecting these guys, we have this little line right here. That's pretty much our new threshold based on the slider. So after I select the threshold, the better threshold that I want, I'm going to go ahead and delete rejected. And I'm going to hit yes. Okay. By doing that now, I'm able to reduce the error level or the error rate on this shot. And by deleting the rejected, all the red elements are gone, all the rejects. So let's go back to your user track and you see how we lowered the error rate. So the next thing that we're going to do is we're going to go to max track error and hold down the command key to select error track. All right, and we could also see the little error in here. So what we're going to do is we're going to use the second slider right here, and we're going to reduce this a little bit more to kind of chop away some of those errors and lower it kind of close to 1. Let's try 1 and see how much of those elements are gone. And that's pretty good. So let's go ahead and delete rejected again and hit yes. And you see how much of those are gone. Now, in order to remove the oranges here, what we're going to do is we're going to delete unsolve. So click on that and hit yes. And you see all the unsolved trackers are gone. So the next stage is, after we got that, you see that the solver error got really, really low, close to 0.5. So what I'm going to do is I'm going to go ahead and update the solve. And what that is going to do is going to recalculate based on the changes that we did. And it should take this error just slightly down even more. So let's go ahead and hit update solve. Don't hit solve, just update the solve. Okay. And through the same frame range. And now that we updated that solve, you can see this turns back to 0.55. Now you get this guy right here. So if that happens, that means that hits the next higher level on the threshold. So one of the things that you could do is you could right click and you could delete the track. All right. And another cool thing that we have is that you will see that we have two little X's. We have a black X and we have the green X. And essentially the green S is the actual 3D point in space versus the black S is the original 2D tracking point. So when we see this error rate right here, essentially what it's saying is how far away in the average of all these trackers is that original 2D track from the 3D track. Okay, so the closer we could get those two, the better the solve will be. So essentially we call that a reprojection error, and that's what those guys are. It will show you a per frame error and a reprojection error in there. And that's what we're trying to solve, and that's what we're trying to remove when we're tweaking the error rate, is that reprojection error. Like I said, the lower you can get it, the better it is. You will see some things like this, you know, some of them are far away. And one of the ways to see if that track is really good or is really bad, or if you need to delete it manually because the actual refinement section didn't got it, you could actually stand on top of the track and you could actually see the error level and the length, how long it actually tracked that feature versus the max error versus the reprojection error. So essentially now that we have that, you could actually decide to manually go ahead and delete some of those points that are very, very exaggerated on their offset. In this case, that point is not that bad, but we could actually delete it. By some reason you weren't sure about it, you could delete the selected. Now watch out how many points you delete, okay? So now that you did that, let's go ahead and see if that affected any of the part of the solve. So let's go ahead and update the solve again and see if that affected anything. And we'll see that it only take it 1 point down, which anything that we do is good. You will see a little red on the back because now that is the limit of our threshold. That means that goes all the way to the top of that threshold. So let's go ahead and delete that one. We don't need it. Okay, so now that that is said and done, we pretty much have our error lowered. So the next stage is to go ahead and create a 3D scene. So that's the last step, and that's our export step. Okay, so that's the last step on this analysis and exporting data out of the 2D image. So let's go ahead and try it out. Let's go ahead and select Scene Plus. All right, and what that is going to do is going to create a whole 3D scene with the camera and the footage all linked together. Now, if you want to know a little bit more, just stand up at one of those features, and you're going to get this pop-up help, and it will explain every single one of the options that you got in there. So let's go ahead and hit Create. And now you will see that you get your whole 3D scene created, and that's essentially what we got here, the whole 3D setup. All right, create it for you. Now, we didn't do any type of lens distortion, so that node can be deleted. Let's go ahead and hold down Command to create a new dot node so we know exactly where things are coming from. So I'm going to give myself some space. I'm going to go ahead and create another dot node here and just connect this from here to here. All right, just to kind of keep it organized and tidy up. I'm going to move the camera tracker to the top there. All right, so essentially this is a whole 3D system. When you actually create the Scene Plus, you're going to get a new point cloud data that we're going to see it in a second. We got a new scene node where you're going to connect the whole hierarchy of your 3D scene. We got the camera, that is the information that got extracted from the 2D plate. And then we have the scanline render that it pretty much allows us to render all the 3D scene and make it into 2D imagery. So if we actually look through the scanline render, you're going to see this whole point cloud system on top of your footage. And essentially all those little points are in reality 3D points. So if you hit tab on your keyboard, you're going to see that now that's the point cloud data again, but now they're fully 3D. That means they're actually kind of geometry in space. So what we're going to do is, the next thing is to line up the geometry with the environment, with the world. So if we look at this sideways, you're going to realize that this is the actual ground that we see on the footage. But right now it's slanted. It's not respecting that in the world. And you will see that the camera is actually on the floor of the world. It's not really respecting where it is on real world. So if we look at this, there's actually a person holding this camera high above, right? Kind of in the eye level. So what we need to do is we need to set something that we call the coordinate system. So first we're going to start with the ground plane, then we're going to add some distance constraints in there to establish the scale of the scene. And right now the scene is really, really tiny in the world. And this blue grid means we're working in centimeters. Okay, so what we need to do is we need to tell it how far away things are as well, so it scales this scene accordingly to the world. So let's go ahead and start with that process. So the first thing that I need to do is I need to go back to my camera tracker. Let's go ahead and select it and hit 1. So we're going to have all the points. And the next thing that I'm going to do with these points, and I'm going to select in the ground plane. So I'm going to select a couple points that I know are going through the ground, okay, by holding down Shift and marquee selecting them. And then those points that I select, I'm going to hit Tab. And I'm going to make sure that they're actually going through that flat area of my track. And they are. So you will see them in yellow. They're highlighted yellow, meaning that they're actually selected. And you see that they're all following exactly the same plane. So what I'm going to do next, I'm going to hit tab again to go back to my 2D. I'm going to go ahead and after I selected those little guys, I'm going to right click on top of one of them. And I'm going to go to the ground plane, set to selected. And they're going to go and turn into magenta color. And now you will see that if I turn back by hitting tab back to my 3D view, you're going to see that now they're on the ground. That means every single point that I selected now is going through the ground plane. Okay? So the next thing that I need to do is I need to set a Z pass or a Z axis. And in this case, you will see the Z is left to right instead of front to back. So I want my camera to respect that. I want my camera to be traveling in the Z axis. So I'm going to go ahead and set a Z plane. So for that, I'm going to find 2 points. They're actually on my Z direction, right? Front to back. So what we're going to do is let's go ahead and try to select 2 points that are closer together. So say these two, right? Say that one and that one. And let's hit tab, make sure that they're actually on the Z plane, and that's fine. Make sure that they're on the ground as well, and that's fine, so they keep constant. And right click, ground plane, set to Z. Let's take a look again. Okay, so that worked a lot better. We can see that the wall is going through the front like that, and everything seemed like it's oriented now to that Z axis. Okay, so now that we have that, the next stage is to set the distance constraint. So I want to make sure that this scene is scaled correctly. So it doesn't need to be 100% accurate, it just needs to be kind of the right scale. So I'm going to say scale is relative essentially in the 3D world, but what I'm going to say is from this point to this point, I want those 2 points to be exactly 1 grid unit apart. So in this case, 1 grid unit means 1 centimeter apart, even though in real world that will be probably 1 foot. So essentially what I'm going to do is, again, the scale is relative. I'm going to select 2 points that I want to set the distance constraint to. I'm going to right click. I'm going to go to the scene and add scale distance. When I do that, some of you will actually see 2 points going from side to side. Some of you won't see the points. But how you figure out if it created or not, what you're going to do is go to your scene, okay, the scene tab in the Nuke's camera tracker, and you will see now the distance constraint there. So what I'm going to say is, I'm going to go back to I'm going to hit tab so you guys can see what happens. Look how small that scene is. And I'm going to say, create that little element that I selected, I want that to be 1 centimeter. Like if 1 centimeter will be equal to a foot or to a meter. So again, it's relative, but we're gonna make it 1 centimeter. That is that blue grid right there, and we're gonna hit enter. And you see how the whole scene now scaled. So that little section that we measured for that box now is equal to one of these grid units. So that means it's 1 centimeter, and that will set your scale for your whole scene. Now, like we said before, the next stage is to check to make sure that everything is working out. So we're going to look again to the scanline render, hit tab, and now we got to make sure that all these little points, nothing got offset and everything's working correctly. So let's go ahead and hit the back arrow like that, and let's hit play and make sure that nothing is sliding. And what I see right now, some of you might get perfect out of the bat and some of you might not, but what I see right now is that when we're playing this, I could see that something is happening, something is sliding. And that tends to happen in Nuke. When we actually set our coordinate system, we have to make sure that the rotation of the camera is actually set correctly again. So for this, what happened was is very simple. We're going to go to the camera, and we're going to go to the rotation order right here. And we're going to change it from XYZ to ZXY. Okay? So we set that, and let's go ahead and hit play again. And you will see that now all your points, they don't slide or anything like that. They're actually all static exactly where they need to be. And I will show you an example of the before and after that so you can see the difference. So now you see that there's no point sliding. You will see some points that are floating on air, stuff like that, but that's not necessarily an error. That's just the way that we're looking at it. Okay, but right now you see that these points stay exactly on the same position all the way through the sequence, the same as this point and that point and so on and so forth. So now that we have that information and everything is working correctly, again, like I said before, sometimes you will see a point in space. Remember that we're interpolating 2D data. The idea is that all these points are, the majority of the points are holding on the same position all the way through the sequence. All right, so let's go ahead and change it again so you can see it on what it was before, XYZ. Okay, and you can see that right there we see a slide. You see that it kind of snaps back in, and again, that's because of this error right here. So there we go. So now you see that it doesn't slide, everything's holds. So now we're good to move on. So on our next stage, we will go ahead and create the clean plate. So for this, let's go ahead and start with that process. In order to generate our clean plate, the first thing that we're going to do is we already know that the track works and everything is good. We're going to save it at this point. And we're going to go to the camera tracker point right here. And these are the point cloud data that you guys see on 3D. And we're going to go ahead and disable that so we can turn it off and we can start our process. So the next thing that I got to do is go back to my camera tracker. Double click on it and click on camera tracker again. And just move through the points right here. And hit 1 on your keyboard to load the camera tracker. Now what we're going to do is we're going to select those same 4 points that we selected before. Or any other point that is actually going through the ground. And we're going to create a new geometry that follows exactly the same motion in the same plane. So what we're going to do is after you select those 4 points, the new geometry that we create, like a card in this case or a plane, is going to pass through all those 4 points, the selected points. So let's go ahead and right click on top of one of those points, create, and let's create a card. Boom. Now when you do that, you're going to see 2 things happen. You're going to generate a card, and if you hit tab and go to your 3D view, you're going to see that there's a new geometry right there in the middle. Now it's not big enough. Okay, so let's go ahead and first connect it to the scene so we know it's actually working through the scene. And the next thing that we're going to do is we're going to make it big enough so it actually covers the area we want to clean. So Command and Shift to do the scale. And let's go ahead and scale it so it covers at least the area that we want to clean in our footage. So essentially, I'm going to scale it that way. And then I'm going to move it slightly down and scale it on the y-axis there. Okay, Z up and Y is front. So now that we have that, that's enough for the area that we want to clean up. Okay, and let's go ahead and take a look very quick through the camera in 3D. So I'm going to go to the top here, make sure that you select the scanline renderer now, hit 1. And I'm going to go to the top, and you see the 3D camera? I want to look through that 3D camera. So let's select it here, camera 2. And now we're going to evaluate the motion. So you see, essentially that's the area that we're going to be painting, right about there. So right now the plane is covering exactly the area that we want to paint on. So that's good. So let's move ahead. So the next stage is to figure out how we're going to go ahead and take this section and remove all that information from there. So if I go ahead through my sequence, I'm going to go to the last frame. And you see that's where we see the majority of the information that we need to remove. So again, there's multiple techniques to approach to this. And when I'm working in production, I like to actually go ahead and use the areas. Like for example, this is the closest that we're going to have here. So the most amount of detail will be on this frame for that area that I need to remove. And then as I move along, the most amount of detail will be on that frame for that area, and so on and so forth. So essentially, we're going to focus on just the last frame for now. But essentially, if you want to learn a little bit how do you do the patches for different ones, you could ask us on lecture and so on and so forth. So essentially when we have this, I'm going to go to the last frame where I see the most amount of information. We could go ahead and close right now the card and the camera tracker. All right, and I'm going to use a trick called a node called a frame hold. So this is a frame holding technique which allows us to freeze a frame of the sequence by using just this little node. So in this case, I'm going to freeze frame 101. That is the last frame. Okay, and now if I look through that frame hold, you will see that nothing happens. That means everything is static all the way through the sequence. So before, this is pretty much what we had, using a frame hold. Now it freezes that frame. Now we're going to use a cool technique that you use in prior exercise. In this case, we're going to use a camera projection node. So we're going to go ahead and project this by using a project 3D shader. Okay, you could also access that shader by going through the shaders here, and you're going to see the project 3D. So let's go ahead and connect the image input, that is going to be the frame hold in this case, so that means frame 101, and then the camera input. So it's camera number 2, or in this case whatever camera version you have. If it's 1 is 1. So I like to rename this animation camera, so name cam, okay, so that way I know it's my animation camera. And now we're going to connect that to the image input of the card. So what is going to happen now, if I go to my 3D view and I look at my scanline render, so hit 1 on your scanline render, you see that now the camera is projecting the information through into our card. But the problem is that the actual information is moving. So how we freeze that information on that frame 101 so we could paint it and actually reveal what we want out of it? Well, the actual solution is very, very simple. What we need to do is we use a frame hold here in frame 101. So what we could do is we could go ahead and clone this by using Option K. And we're going to also freeze, by the way, you're going to get this little line right here. You can use Option E to hide it. But again, I'm going to leave it on so you can see where it comes from. So I'm going to hit Option K, and that creates a clone. And you know it's a clone because it has this little C in there. Now, if you're using the PLE version for this, that usually the camera tracker doesn't work on PLE, you don't want to clone it. You probably want to copy it. So essentially what we're going to do is we're going to put this frame hold in between the animation camera and the input of the camera projection on the project 3D node. So let's go ahead and do that. Boom. I'm going to create a dot node here because I'm going to be using this later on. So now that we have this frame hold in there, okay, we're holding exactly the same frame that we're holding here. So now if we look through the scanline render and we go to our render, let's hit tab to go back to the render. Let's go ahead and disconnect the background input because that's the footage coming in, okay? So I'm going to go ahead and look at it without the footage so you guys could see what is being projected in 3D. Let's go ahead and hit play. And now you see that that information, we froze it on that frame. And now we're going to be able to patch those areas that are the affecting areas out so that way we could keep working and cleaning up the footage. So now that we know that that is working, you see it's following the whole motion. So that way it's following perfectly the motion of the camera because we made sure of that. Okay, so the next thing that I'm going to do after that is I'm going to go ahead and after the frame hold, I'm going to start my paint removal process, so my clean plating. So for this, I'm going to use a rotopaint node. And we already know how to use the rotopaint, so this is going to be my clean plating for that specific area. So essentially what I'm going to do is I'm going to go ahead and select my clone stamp tool. Okay. And I'm going to hold down the command key to sample from to. Right now there's 2 circles, okay? The first circle that I have, the one that is here, that's the one that is my source. And the circle that you will have your mouse over, that's going to be your destination. Okay, so what I'm going to do is I'm going to sample from this section. If I minimize the color here, you can actually see where the 2 circles are. So essentially I'm sampling from this area right here. I want to paint this area over. So always try to make sure that your paint is relative to the location of the element that is being affected. So that way you always get exactly the same quality all over. So what I'm going to do is I'm going to paint on that same level right there. And I'm just going to start painting all these guys out. Okay. Now, if by some reason you can't see exactly what is happening, make sure that you select your rotor paint and you're looking through that on your actual viewer. So select it and hit 1. And that way you know exactly where you're painting on. Now, I have this dark so you guys could actually see the destination and the source. But again, that's essentially what we're doing. So try to just paint the areas that you need to paint. If you don't need to paint it, then don't paint it. All right. So essentially, I'm just covering the shadow section, nothing else but the shadow section and the box section. So I'm trying not to affect any pixels that I don't need to affect. So there you go. That's our clean plate there. And it doesn't look repeated because we were using different areas. Now let's go ahead and go with the shadow section here. So let's go ahead and paint that shadow out. Again, you can't see where my destination, my source is. So I'm going to lower the exposure a little bit so you guys could see how that works. Okay. So essentially, I'm just going to go through this. I'm going to go ahead and use a little bit of a magic here, the magic of video. I'm going to pause it, and when we return, it's going to be all done. All right, so now that everything is actually painted, so the next thing is let's go back and put the whole exposure up again. So the next thing that we're going to do is go ahead and go back to your selection tool, so by mistake you don't paint anything. The next thing is you will see that all your clone tools, or all your clones, I did on frame 101. Now, if you had done it in any other frame, you will go back and just select the frame and so on and so forth to get everything done. So what I'm going to do is I'm going to select all the clones, hold on shift, select all the clones. And one of the things that you could do is, one of the ways that you could actually make sure that this doesn't show up all the way through, because if you actually move your timeline from that frame that you painted on, you're going to see that everything that you did just goes away. So one of the techniques to actually be able to get everything throughout every single frame is to make sure that the lifetime is set to all. So it's one way of actually doing it. Now the problem with setting the lifetime set to all, you're going to see that now it works for every clone. So essentially now it's going to be all the way through the sequence. I'm going to click on the outside so I don't select anything. All right. Essentially what that's going to do is throughout the sequence, that roto paint node is going to keep calculating. So in every single frame, all these guys are going to be calculated. So therefore it's going to be covering, using the same strokes, it's going to be covering that all the time. Now, the most important thing about that is that takes resources in calculating every single frame. So one of the things that you could do is, if you already painted on the same frame that you did the frame hold, you could actually use a copy of that frame hold or create a new frame hold underneath this. Okay? And that frame hold, you could actually set it to the same frame, 101. Now, why I have a different frame hold is that some of you might have painted probably in frame 50, you probably in another different frame. So by having that frame hold in there, you could actually go ahead and set it to a different frame. So let's say frame 49 or whatever. Now, the idea of this frame hold is, if by some reason you don't want to use the all method, because this method calculates in every single frame, and let's say we left it on the original frame that it was. So let's say I'm going to leave it on the original frame. So let's say single frame, and I paint this on 101. All right, so let's say I painted that on 101 and it was set like that. The idea of this frame hold is that I'm able to actually go ahead and set it up to that same frame, and now it's going to calculate again throughout every single frame. But the thing about this one is that it doesn't have to recalculate the paint stroke for every single one of those frames, which actually consumes resources. So by using the frame hold, it takes frame 101 and just patches over everything. So it doesn't have to recalculate every single stroke in every single frame, which optimizes your workflow. So that's a little technique there to be able to optimize that. Now, the next thing that we want to do is to only reveal the areas of our clean plate that we painted. Okay, so we don't want to use the same image that we have right here, the whole image, the whole frame. We don't want to use that whole frame to put it back over everything, right? What we want to do is only the areas that I created or the areas that I painted, those are the ones that I want to patch again over the original footage. So for that, underneath the rotor pane, we need a new rotor node. Okay, so with that rotor node, double click on it. Let's go ahead and create a B-spline or a Bezier. Either way, it doesn't matter. Okay, and we're going to go around the areas that we want to keep, or the areas that we want to show over the original. So what I'm going to do is I'm just going to go around the shadow, for example, the shadow section. And that area I want to keep because that's the area that I cleaned up. Okay. And then the other thing I want is the box section. So let's go ahead and click again here. All right. All right. just hit enter very quick. Okay, so those are the two areas that I want to keep, and everything else I'm going to discard. So let's go ahead and go to the roto, hit 1, okay, and we're going to put a pre-molt node underneath that roto. Okay, and now those are the two areas that we're keeping. Now the next thing that we're going to do is select the roto, and in the roto there's two splines that you created, two Beziers. So we're going to go and feather those out a little bit so it's soft fall off against the original. Okay, and now we're going to look at the frame hole again, and that's perfect. And now let's take a look at our projection very quick. So let's take a look at the scan line. Okay, and now we could see on that 3D move, I'm going to turn off the roto. You're going to see that there's offsets on the roto, and that's because now we're looking at it through a 3D motion. And essentially, we're not going to see the same alignment of the roto, but the rotos are okay in the alignment. They're actually okay in the section, and we project those through into 3D space, so that's why you see the misalignment. So essentially, now that we have that, let's go ahead and hit play. And you're going to see that now the areas that we patch are actually holding on, and they have the camera move. So now it's time to comp those over the original plate. So that's good. Perfect. They move correctly, they move in the right perspective. So let's go ahead and comp those over the original plate. So remember this little background input that we had connected to the original? What we're going to do is we're going to put a merge operator, even though you can connect this background in. And let's put this on B, and we're going to put the new strokes that we generated on A. Let's hit 1. Okay. And now you can see that we have the original footage that is coming on the B stream and the patch that we did, the clean plate that we did on top that is on A. And let's go ahead and hit play, and let's take a look at our clean plate. All right, so there we go. So now you see that you have a complete clean plate on here. Everything is working, everything is moving correctly, there's no sliding, and you can't see where one starts and the other one ends. Now, we were in production, we would do a couple of other things to this plate. Essentially, every time that we do a clean plating and we paint, we need to remove the noise. So we will do a denoise over here to actually remove the noise before we actually do the paint job. And that way, after the fact, after we finish and we're compositing that over the original element, we will actually put a grain node in there. So it will actually regrain the plate by using either a grain node or by using an F regrain. So there's different ways of actually regraining a plate. And that way we'll create the grain back. Of course, this is not the exact grain for this, but you will go ahead and tweak your grain, make it smaller, and make it less intense in some of those areas until you get the grain back exactly to where it should be. And that way now you will regrain the plate, creating the effect that both of them never were mismatched. So essentially, I'm going to delete this grain because we don't need it right now. I'm not grading you on that, and we are not taking a look at those things. What we're looking at is just the basic techniques. So essentially, now that we have this, let's go ahead and create a very quick backdrop node for the areas. So let's should be on that. And that's going to be your clean plate. So CP for clean plate. All right, this is going to be your 3D section. It's really good to maintain organized all the time. So I'm going to go ahead and create one. So I'm going to hit tab backdrop node. Now, Shift B is not going to work for you guys, even though I said it. It's just a shortcut that I have set up for myself. So you hit Tab, Backdrop, and then you will create the backdrop node. So this is going to be my 3D section. All right, and change the color if you want to. All right, that way is a lot easier for you guys to follow along everything. So that's going to be my 3D section, and this is going to be my original footage. So Tab, Backdrop, and this is going to be my footage. All right, and this is always a good idea to keep organized. And then the last but not least, it will be this section that is my track. So I'm just going to move this up and create another backdrop node and make that my little track section. So TRK for track. And that way you can keep everything organized, everything straightforward, and it will look nice. And you will have a very, very nice script set up for this process. So essentially, that's the process of creating a very basic clean plate for the specific footage. So that's it for today's podcast. Now, if you want to go further ahead, you're going to have two videos that you could do. So you're going to have the first one and the second one that you're going to be doing. And essentially, this is the same process that you're going to follow throughout the whole thing. Now, if you want to do anything extra, like adding logos or anything like that, You're going to do those in the position of the frame hold. You'll probably add the logo and then project it to the card or whatever you want. So you're allowed to explore and stuff like that. But the base thing that we want you to get from this is how to generate a clean plate using Nuke's 3D camera tracker and how to actually match geometry to 3D environments. So that's essentially it. So we went through the process of generating a very quick clean plate. We went over the camera tracker. We went over some of the settings of the camera tracker and how to adjust them. And then we went over how to fix the animation camera issue after we set the coordinate system. And we show you how to create a ground plane and how to set up the ground plane as well as a distance constraint for the sense of scale of the scene. And then at the end, we went over how to generate a clean plate and how to go back and patch that on top of your original plate. So that's it for today's podcast. I hope you guys enjoy it and see you in the next one.